Welcome, students. Great to see you guys all here today. Looks like we are going to go over the worksheet on pages 283 to 284. Number one, in ancient times, how many planets did astronomers know about? 5. They only knew about 5 of those. You guys make sure you know that actually. Number 2, who found the most important evidence for the heliocentric view? That would be Galileo. Galileo did some extensive research regarding when Copernicus had this idea, wasn't very popular about the heliocentric idea of the universe. Galileo came along and he really solidified that with valid evidence that the Earth and all the planets actually circle around the sun. Number 3, in what path in which planets move? That would be ellipsis. They move in an elliptical manner. Kind of interesting. Planets don't really move in a circle. You can see on pages, let's see, 282, 283, those were circles. They thought that everything was circulating around each other. That's not necessarily true. They're actually moving in an elliptical manner. Number 4, what does an ellipsis have that a circle actually does not have? Well, that would mean there's no center point. It's kind of interesting if you think about a circle. A circle has one center point and then things going around them as well. Also, kind of interesting. Hold on, we gotta put this on here. There we go. Okay, so not only that, for an ellipsis, you actually have 2 points, and then what's going to happen? You're going to have more of an oval shape now, not really a round shape, but an oval shape, and that's the path in which all planets are in fact traveling. Not only that, three laws that Kepler was talking about is planetary motion. Before we get into that, I'm actually going to skip over that one because I'm going to illustrate that on the board once we start our class period for today. Number 8, what is the furthest distance the Earth is from the Sun called? That would be the aphelion, A-P-H-E-L-I-O-N. Make sure you guys get that written down for the worksheet that we had yesterday. Number 9, what is the closest distance from the Earth, from the Sun? What is that called? The perihelion. That's where that would be located. Notice the difference between that. As the Earth or any type of object is going closer to the Sun, they're going to actually speed up. Once they go away from the Sun in their elliptical manner, they're in fact going to slow down. Number 10 says this: what is the measurement in which the planet's average distance from the Sun is called? That is astronomical units, also abbreviated as AU. And then number 11, true or false, Kepler discovered his second law of planetary motion first. That is actually true. There's actually a box on page 284 that says dig deeper right there. Although Kepler discovered his second law before his first, at some time or at some point in history, the names were accidentally given the wrong law. So kind of interesting to think about that as well. Homework, what was that? Well, numbers 1 through 3. What is the current view of the solar system that we accept today? Heliocentric view. That is what we believe. Make sure you guys understand that and have that written down correctly, because I know some of you actually didn't put that correct on your homework. So make sure you guys do that. Define perihelion. Well, of course, it's going to be the closest distance from the Earth that is from the Sun. And then number 3 is AU with our abbreviation for astronomical units as well. Hopefully you guys went on the ThinkWave and uploaded our new worksheet that we're going to go through today. We're going to go over pages 285 to pages 286. And I'm kind of looking, we might have to tilt this up a little bit for our demonstration for today. So first of all, the first question that I want to ask you guys, especially if you guys actually look on your worksheet for today. Number one, draw Kepler's 3 laws of motion and use the Earth and the Sun. So this is going to be kind of interesting. It's time to draw. I love drawing, of course, in science classes. I'm always doing that. So this is one of our opportunities that we can do for us today. So the Sun. So first of all, the very first law that he states is, in fact, that orbits go in an elliptical manner. Notice that it's not a circle. They're going to go in an ellipsis. So there we go. We have 2 focal points that are pretty much happening. And I think probably the best way in order for us to kind of see this is that we have this oval shape. This is kind of how these planets are traveling around our solar system. I would actually label this as an ellipsis. So E, L, L, I, P. I forgot how to spell that. There we go. E-S-I-S, ellipsis. There you go. So it's going to go in an elliptical manner. That is our first law that we have there. I would write a 1, and I would circle that 1 for this homework that we have. Not homework, kind of seat work, I guess, or working together through our class and stuff. Kayla, looks like we have a question over here. Yes. We're on our very first question for our problems that we're dealing with today. Do you see those? Yes. Did you get it? Okay. All right. Excellent. Very good. So we're going to be working through that worksheet here. Number 1, draw Kepler's 3 laws of motion. This is our first one. They go in an elliptical manner. Hopefully you guys can see on that on Zoom here. I think you guys can. There might be a little bit of a glare there. But it says an ellipsis right there. Number 2, we have this idea of various speeds that the planets are actually going across our universe here. So first of all, we already know, let's just say here's our Earth. We get kind of a dot right here. So first of all, if we have a planet moving away from the sun in an elliptical manner, it's actually going to slow down. If we have this dot right here, let's just say this is a planet or the Earth, and it's going this way, it's actually going to, I don't know how to spell speed up here, there you go, S-P-E. It's going to speed up. That's very important for you guys to understand. I think a lot of you guys on your worksheet didn't quite understand that. Very important for us to know here. When we have a planet that is orbiting the sun and is getting closer to the sun, it will speed up. Make sure you guys understand that. That is the second law. So what I'm going to do, hopefully you guys do this as well. I'm going to put a number 2. Hopefully you guys can see this. A number 2 right here. And this 2 defines the various speeds in which the planets, in fact, orbit. So make sure you guys write that down. Our last one, however, that would be regarding our period of time. That's going to have a period right here. So first of all, if we have a planet, let's just say that it starts right here. Here's our starting point right there. Okay, I think you guys can see it. But then also we're going to have an ending time. So we're going to have our planet go 365 days out of the year orbiting the sun, which is our Earth, is in 1 year. And then we can also have the moon. That's going to go in a full orbit or a full period around 29 days or so. So here is going to be our ending point right here. So here's the start, and this is our end. All of this actually makes up our very last point. I think you guys can see that. Yes, you can. Fantastic. This is going to be defined as our period. There's an O between the I and the E. So make sure you guys understand that. I'm going to give you guys like 10 seconds to write that down. Make sure you guys have it completed. All right, there you go. So that was 10 seconds. Hopefully you guys have that written down and you guys are all set, ready to go. Here we go. So first of all, Let's talk a little bit about the planets. First of all, we already know that. We already know Earth, that it's in fact a planet. But I want you guys to know that there's two different types or varieties of planets that we can get here. So first of all, the first one is the inner planets, and the second one is the outer planets. What are the inner planets? You see on number 2, list the planets in order, starting with the inner planets and then moving to the outer planets. What I'm going to do, what I did in my notes, I put outer, and I put, actually I should probably put inner planets first. I think that's confusing. So let's put inner planets, and then outer planets, of course. So there we go. So we have here, first of all, we already know the first planet. That's going to be Mercury. You can see on page 285, this has the inner planets right there. So it's going to start with Mercury, Venus, Earth. That's where we live. That's pretty cool. So we have Earth, and then finally Mars. Though in our study, actually, we're going to actually go through some different ideas with each of those planets. We're going to go into specific details of what each of those are and some characteristics that those are as well. So I'm kind of excited about going through each of those. So first of all, we're going to have Mercury. Mercury is kind of an interesting planet. Don't want to go into too much detail. I want you guys to know the order in which it goes. So Mercury, Venus, Earth, and Mars. Those are the 4 inner planets that you guys need to know. We have the outer planets, of course. Let's talk a little bit about those. So Jupiter, Saturn, Uranus, as well as Neptune are the outer planets that we have here as well. So very cool, or kind of interesting that we can see here. Now, something interesting about the outer planets is that most of them are a little bit bigger than the inner planets. And not only that, you don't actually see Pluto in here. Kind of interesting, because Pluto is no longer represented as a planet anymore, because its gravitational pull is not based on the sun, which the other planets in fact are. So kind of interesting, cool as well. But we'll probably get there sometime. So make sure you guys have that in order. We have the inner planets. So I would have in your notes here the inner planets, and then we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, as well as Neptune being that bright orange one as well. So we've gone through the 3 laws of motion. We've gone through the order of the planets. So now, how in the world, if you think about this, how are these planets suspended in space? How are they actually orbiting and going around the sun in this elliptical manner? Well, it's kind of interesting because there's a man named Sir Isaac Newton. Now, Newton has established a lot of laws for us that we still use even today. And it's very important for us to realize that one of the things that he established was called gravity. Gravity is a very interesting thing. We experience gravity all the time. I was watching a documentary on the moon, and I believe they said that the gravity on the moon is about 1/6 the amount of gravity that is on the Earth. So kind of interesting. Something kind of strange about gravity is that if you have 2 objects, they're all affected by gravity. So if I have my football here as well as a pen and I drop those, they're both actually going to drop at the same time. Kind of interesting, kind of cool. And this is actually one of the science experiments that Galileo did. He said, it doesn't really matter how big the object is. It doesn't matter how small the object is. They are all affected by gravity, and that's one of the biggest things that he established with the planets. And when he was kind of studying that, well, are the planets affected by that as well? So let's kind of talk a little bit about gravity here. Well, what is gravity? Well, it's actually the force of attraction that exists between 2 objects. This is kind of interesting. Now, notice that this gravity doesn't really deal with relationships, okay? Just because you're attracted to someone doesn't mean that's called gravity, okay? That's just called being a junior higher, I guess you can say. But anyway, we need to continue because we've already talked about lightning and all that other stuff. So we need to continue with gravity, okay? So gravity has this other idea, is that we have attractions between objects with gravity here. One of the biggest greatest gravitational pulls that actually affects all of us is going to be the sun. The sun is the biggest planet in our universe, And since it is the biggest and we revolve around it, it's going to affect all of the other planets. And since it affects all the other planets, the sun is has the greatest gravitational pull that you can actually experience. So kind of interesting as well as kind of cool also. So Newton actually found the law of universal gravity. So I've already kind of explained this idea. When you have two objects and then you throw them down off of a cliff or something, they're all going to go at the same speeds to the ground. However, what happens if you have a feather? I have a feather, actually, a peacock feather over here I could take, and then I have a pen, and if I both drop those, what's going to happen is that the feather is actually going to kind of stay in the sky a little bit, kind of whisk down a little bit, but the pen is going to go really quickly to the ground. Well, the difference between those is that the feathers have some air resistance, and sometimes when you have air resistance, that's when it's going to really affect how fast and how effective gravity is upon an object. So kind of cool and kind of interesting as well. So I want to make sure we go through this idea of gravity. I'll try to look through a couple things here for us to understand. I actually might throw you guys over some questions, see if you guys are understanding this as well. But first of all, before we continue that, do you guys have any questions? Any questions? Yes, it looks like we have Arthur. Arthur, do you have a question? Yeah, okay, no question. All right, we'll lower your hand then. Anyone else? Any other questions? Anyone confused? All right, excellent. So let's go here. So let's see here. I'm going to get out my papers that you guys have been doing here. Ask you guys some questions. See what you guys actually know. What galaxy are we in? First person to raise their hand. Actually, I think that was Nicholas Razan. Very good. What galaxy are we in? Milky Way. Very good. Excellent job. Way to go. All right. So what includes the sun, planets, a planet's moon, and other small bodies that orbit the sun? What would that be, Gustavo? The solar system. Very good. If we have an object circling around another object due to gravity, what is that called, Joanna? An orbit. Very good. Excellent. You guys are doing a fantastic job over here. Nice. All right. So what is the path in which planets actually move? What is that path called? Linux. Ellipsis. There you go. Very good. Excellent. Yes. Wonderful. All right. I also want to go through a couple things here, first of all, especially this idea of, let me see here. Let me try to erase some of this so that you guys aren't looking at this here. All right, very good. All right, so let's kind of go over this. So first of all, what is the very first law of Kepler's, what is it? Laws of planetary motion. What is Kepler's very first law? What would that be? All right, looks like Jed. There you go. Very good. Excellent. Yes, we're going to have this ellipsis. Hopefully you guys eventually maybe get to geometry or to study this here. So we're going to have this elliptical orbit that we have here. It's almost an oval shape. Very good. Number 2, what is Kepler's second law of planetary motion? All right, Joanna. Okay, all right, that's a good explanation. Very good. Make sure you don't get that confused. If you have the Earth going away from the sun in an elliptical manner, it's going to slow down. If it's going from the, I believe it's aphelion, and then going to the sun, it's going to speed up. So very good, Joanna. Excellent. All right, so we have number 3. What is our very last one that we have here? Arthur? Okay, what is your question? It's a good thought process. So I'm thinking we still have to go around the Earth around 365 days out of the year, and I believe that is correct because we do have to have daylight savings, and so therefore we always have to move our clock forward, I believe, and that's what we just did around like a month ago or so. So kind of that same idea. Does that make sense? Okay, excellent, very good. All right, Kathleen, you have a question as well? Okay, then what is the answer? The period, very good, excellent. So kind of interesting. We're going to have a cycle here. We're going to have a start, and then we're going to have an end in which the planet actually orbit. Very good, and that is going to be called the period. Excellent, very good job. Here's the deal, guys. You can see on the bottom of our worksheet here, it says no homework. Oh, yeah, of course, it is Wednesday, so there is no homework. However, you do have to have this page filled out and submitted by 3 o'clock tomorrow. Make sure you guys have that submitted by that time. Yesterday's worksheet is due today at 3 p.m. So you guys have about 40 minutes to get that worksheet uploaded and correct as well. So make sure you guys do that. As of now, that's all that we need to go over. If you have questions, stay on the line. If you guys don't have any questions, we'll see you later. Have a great rest of your day. Gustavo, question? Okay, so, okay, all right. Let me take a look here for you. All right, so let's see here, making sure this is all correct. Okay, interesting. So, Gustavo, you sent me the very first days, and you got a good grade on it. But then it looks like you need to send yesterday's worksheet. I haven't quite gotten that worksheet yet. So yesterday's that is going to be numbers. What worksheet is that? Pages 283 to 284. (283) to pages 284. You need that worksheet, and you need to submit that. Okay, we'll go to Musa. Musa, you have a question? No, you need to submit it online. Submit it online, take a picture, and it'll be all set. Okay, excellent. Mr. Linick. For 4 and 5, they are actually in your book. You need to go to your book and try to find the answers. They are in there. All right, excellent. Any more questions? Okay, Philip, I'll unmute you. Okay. Say that one more time. Don't think cool. Oh, good question. Let me see here. I'm looking online at this point. Yes, I did, and then I believe you did correct it. I think you corrected it. Looks like you did. Okay, yep, you should be all set. Yep. All right, and then we have Caleb Love. Yes. So do you have, what are you using Word? Okay, what you can do, do you have something that you can take a picture of it and upload it? Okay. All right, so what I would do is I would at least fill out the worksheet, and then if you send me a picture of all the 3 laws drawn out, then I would accept that. Does that make sense? Okay, great. Well, I'll be looking for that. Yeah. All right, and then Gustavo, yes. I believe it's 283 to 284. Today's is 285 to 286. Okay, interesting. So if you go to, do you have your assignments pulled up? Okay, all right, and let's see. Let's see here. If I can, because it looks like a lot of other people got it and uploaded it. So It looks like, do you see the homework assignment for 281 to 282? Okay, there should be the one either under it or over to the right of it that says 283. Okay. Mhm. Okay. Hmm. Strange. Okay, because I know when I uploaded all these assignments, I put like ES 10.1 pages, whatever. So maybe it comes up and you see ES, but you need to keep continuing looking to the very end of that to see if it's pages 280. Yeah, two. Yes, that is it. Okay. All right, no problem. Okay, so Evan, are you still here? Do you have a question?